This is the video for 8.6 day 3 notes. All we're doing is looking at restricted domain and complete solution equations, but the arguments are going to be something other than just x. It might be 2x or 3x. So we just have one extra step that we're going to have to be aware of. So instead of saying that x equals, your unit circle value plus 2 pi k or whatever that may be, you're going to have 2x equals, and then you're going to have to divide both sides by 2 in order to get x by itself. So that's really the only other thing happening in these problems. We're going to do number 1 and number 2 in this video. So for number 1, we do have to get cosecant by itself. Notice that the argument is 2x here. So I'm going to add 4 to both sides first and divide by 3, which is equal to 2. Now this is cosecant, so we need to use the reciprocal function, which is sine of 2x, and then we need to take the reciprocal, so that's going to be 1/2. So what you want to be thinking of here is, where does sine equal 1/2 on the unit circle? And that would be pi over 6 and 5 pi over 6. So what we have is 2x equals pi over 6 plus 2 pi k, and 2x equals 5 pi over 6 plus 2 pi k. Now I added 2 pi k because those unit circle values were not across from each other. So now the only thing you have to do is divide everything by 2. So this is going to be x equals pi over 12 plus pi k. Same thing to the other side. So now we have x equals 5 pi over 12 plus pi k. So this is your complete solution. Now we're going to talk about our restricted domain solution. Okay, so I reorganized my screen a little bit. I was running out of room. So what I have is I still have the complete solution, and we're going to get ready to find the restricted domain solution. So there's a couple different ways that you can process this and think about this. Whatever way works the best for you. You can use your calculator, or you can make sure you have common denominators, adding fractions, whichever you prefer. So what I'm going to do is I look at my restricted domain 0 to 2 pi. I also notice that my values are fractions that are over 12. So what I like to do is I like to rewrite my domain with a common denominator. In this case, it would be 12. So this would be 0, and then 2 pi with a denominator of 12 would be 24 pi over 12. And then what I do is I look at my first solution, pi over 12 plus pi k. Well, pi in this case is going to be 12 pi over 12 in order to have a common denominator of 12. So what I do is I take this first solution and I list out the first solution, which is pi over 12. And then the next solution would be adding pi, which in this case is 12 pi over 12, so that would be 13 pi over 12. And then I continue adding pi, which is 12 pi over 12, until I get out of the domain. So if I add pi again, which would be 12 pi over 12, I would get 25 pi over 12. Well, I'm restricted with my domain, and I have to stop at 25 pi over 12. So I know that this one's out. So now I'm going to look at my second solution, which was the 5 pi over 12 plus 5k. So I'm going to start off with just 5 pi over 12. That's the first solution. And now I'm going to add pi until I'm no longer in the domain, which is the same as 12 pi over 12. So next would be 17 pi over 12. And then the next one would be 29 pi over 12. Well, 29 pi over 12 is no longer in the domain. So your restricted domain solutions are going to be these 4 values. So we'll write those out as pi over 12, 13 pi over 12, 5 pi over 12, and 17 pi over 12. Okay, number 2. The first goal is to look at that equation and we need to get cosine by itself, but we do want to notice that the argument is 3x, so we need to be careful of that. So I am going to subtract 2 to both sides and then divide by 3. And that simplifies to 1/2. So we need to be thinking, where on the unit circle is cosine positive 1/2? There's 2 places, pi over 3 and 5 pi over 3. So instead of x equals, we have 3x equals pi over 3 plus 2 pi k. And then we have 3x equals 5 pi over 3 plus 2 pi k. So those two values are not diagonally across from each other on the unit circle, which is why we're using 2 pi k. So now we need to solve for x. So we're dividing everything by 3. So I have x equals pi over 9 plus 2/3 pi k. Same thing for the other solution. So I have x equals 5 pi over 9 plus 2/3 pi k. This is your complete solution. Now we're going to look at restricted domain solution. Okay, I reorganized my work a little bit. You still see my complete solution, and now we're going to work on restricted domain solution. So again, you can use your calculator for this. Just for the purpose of the video, I'm going to write all this out. I like to just get a common denominator and make it a little more visual for me. So I'm taking my domain, and I notice that my denominators for my 2 solutions have a denominator of 9. So I'm going to rewrite my domain to also have a common denominator of 9. Okay, I'm going to be adding 2/3 pi to each of these, so I'm also going to convert that to a common denominator, which would be 6/9. So let's take the first solution, which is pi over 9. And we're going to add 2/3 pi to that, which would be the same as 6 pi over 9. And take away that plus sign. And we would get 7 pi over 9. Now, if I'm looking at the domain, I can already tell that those two actually are not in the domain, so I need to keep going. So the next one would be 13 pi over 9. That one's in the domain. And then the next one would be 19 pi over 9. Well, I'm already out of the domain again for that one. Okay, now I'm going to look at the second solution, which is the 5 pi over 9 plus 2/3 pi k. So in orange there. So as I start writing these out, the very first one is 5 pi over 9. We can already tell that that's not going to be in the domain. The next one is 11 pi over 9, then 17 pi over 9. Remember, I'm just adding 6 pi over 9 each time, which is the equivalent to 2/3 pi. And the last one is 23 pi over 9, and I can already tell that I'm out of the domain. And remember that 5 pi over 9 was not in the domain either. So as far as our restricted domain solutions go, it looks like we have 3 that were in the domain. So we can write this out. 13 pi over 9, 11 pi over 9, and 17 pi over 9.